Hey everybody, previously we've discussed how kinematics is the language to describe the motion of objects. And I want to take just a little bit of time in this video to talk to you about something that's been termed as the ladder of abstraction. Now we said there are several ways to describe the motion of objects. And that can be in language, which y'all tend to think of as word problems. But simply think of it too as, in real life. See, you're there watching the football game, and somebody calls you on the phone and that's not there and says, "What's going on?" So you're on the phone and you describe what the motion on the field in language. So that's something that we do all the time. Another way that we can describe motion is we can diagram things. It's always, think of Wile E. Coyote whenever he's drawing on the wall of the cave and figuring out how he's going to catch the roadrunner. I mean, that's kind of like a diagram too. Draw the problem that you're trying to solve. Something we've already done in class is look at those fundamental dimensions that are measurable about an object or an event. And if you want to relate them in some way, a good way to do that is graphically. So we'll graph a lot of relationships in class. And then ultimately there's the algebra, the way to express these relationships we're talking about mathematically. And what I want you to understand about the ladder of abstraction is these are not separate events. My real goal in this class through the semester and through the year is for you to start seeing an algebra equation and being able to explain that algebraic expression just in language. I want, when you read the algebra, I want you to in your mind, I want you to be able to describe it just in English. And when you see a diagram, not only do I want you to be able to describe it in language, I want you to start seeing it algebraically. I want you to start seeing it graphically. I want you to be able to juggle these four different types of abstractions almost equally. And that's a big task, but it's a goal that I have in class. And so now let me give you a real quick example of what perhaps I'm talking about. What you see here is just a picture of a street here in town. It could be any street, but maybe it's here. We're at the beginning of school, and maybe the question is, well, what's the shortest way to get to school, or how far is it to school from where we are? So, if we were there, this is a picture which is actually a type of abstraction, but let's pretend we're in our car here on the street. So that would be that concrete event. To move along the ladder of abstraction, maybe we go and we pull up Google Earth and we look here at where we are. And let's say perhaps that we're, I don't know, we're off over here. Maybe at this intersection is where we were on the map. Can we abstract this further? Of course we can. The same map, maybe we look at it and we see lines of longitude and latitude, which bring in some mathematics, help us understand the problem that we're looking at. Can we abstract this even further? Well, yes. Now maybe we've got a diagram here. And so what can we do with this? Well, it'd be natural. We've got to keep going down the street. So let's take a look at this. Get me some arrows here. What if we're driving and we say, okay, well, we're going to go down the street and get to Commercial Avenue here. And we're going to drive down the street. Come in here, and then we're going to move across and ultimately park here in the parking lot because we know that the school is located right there. Well, great. Now, can we abstract this perhaps even further? Well, what if we just took the map away and see what we've got going on here? Well, we just got lines on the page. But do we? Is there any way to look at this? Can we move these around? We're going to be studying vectors soon enough. We've got one arrow pointing to the right, one arrow pointing to the left, and part of that cancels, right? So we can add and subtract these distances here. I think I'll leave a little space in there just so that you can see that visually. Now we were starting from that red dot over there, so I'm going to scoot this vector over. And so, what do we have here? Well, let me change the color that I'm illustrating this in, and then let's see where we are. Well, actually, the movement of our vehicle was perhaps along this blue line. And if we look at this here, maybe we see that we start to have a right triangle, and we're trying to find the hypotenuse of a right triangle, and we know that a squared plus b squared equals c squared. And then, well, son of a gun, look at what we've done. We started from being a vehicle on the street, looking to try to evaluate our motion, our movement toward the school, and we used maps and language, and we drew lines on the page, and now suddenly we're looking at a triangle, which is definitely an abstraction, and we're looking at this equation that's trying to tell us something about our displacement from where we were to where we parked our car, where the school is. So that's sort of an example of this ladder of abstraction and what we're going to do in class. We're going to try to start with real events in class, and that's the stuff we're going to play with in class, but we've got to be able to quantify it and describe it some way mathematically. And so we'll be using this ladder of abstraction, and I thought this was worth sharing with you so that you get that idea. And there you go, ladder of abstraction.